As expected today at Game Developer Conference, AMD gave out a ton of more information about FSR 2.0, which should actually compete with DLSS a lot more directly than their FSR 1.0 technology, which did have its advantages in terms of ease of implementation, but definitely did not live up to the same image quality. However, this could come with its own set of pros and cons. We've got a ton of info for you. Is it going to support a bunch of GPUs? When is this coming out? Is it open source? Could it ever be added to drivers, RSR? I've got a lot of my thoughts as well as the official information from AMD, and I'll link this in the description of the video. So one piece of information that we're getting first here is that this will support DX12 and Vulkan, although the Vulkan support is listed as being expected later. Which does bring up one of my major concerns, is that when this first launches, I'm wondering how many games will be supported. And some of the big news, and we'll see it later on here, is that this will be supported as an easy plugin for the Unreal Engine 4 and 5. So that should already make it easy to add to a bunch of games. We'll talk more about that in a bit. Now, the main thing here is that this is going to be open source, which is fantastic news, as well as it is a temporal upscaling solution, whereas FSR 1.0 was a spatial upscaling solution. Now, what does that actually mean? Let's jump in. Well, actually, before I get quite there, let's actually take a look at this scene, because AMD does claim that this will deliver, we're shooting this video in one take, sorry if I misspeak, deliver similar or better than native image quality. So what's up with that claim? Well, this is something that people also say about DLSS from NVIDIA, that in some situations it can deliver better than native image quality. In general, this usually only happens in still screenshots, and then in motion it tends to break up a little bit. However, when people insist that a game like, some people say this about Red Dead Redemption 2, where DLSS just flat out looks better than native, although in my opinion it has some ghosting and the hair looks a little bit weird. But anyway, I think what they're usually noticing is that DLSS replaces the anti-aliasing within the game, and games that have a very blurry TAA implementation sometimes end up having a lot of advantages when using DLSS. Well, FSR 2.0 is also going to do this. It will be replacing any TAA that the game had already programmed in when you implement FSR 2.0, which is where I think you could get that or better than native other than just in still screenshots. Again, we need some independent testing to see how this plays out, but there we go. Okay, it's also going to support dynamic resolution scaling. That's where you could give a frame rate target and then it'll render to different resolutions as needed to reach that frame rate target, although there's also the quality presets that'll we'll get more information about here. And one of the biggest things here is that there is no machine learning involved, which could have its pros and its cons, and we'll dive more into that as well. So we're gonna go ahead and jump in here. So they outline how it works with this general screenshot. Let me shrink myself tiny out of the way. So basically, you've got the game's render resolution and then your presentation resolution. For example, you might be presenting on a 4K monitor at a 4K resolution, that's the output, but you might render the game at 1440p. And in FSR 1.0, you just had a spatial upscaler where you just had that 1440p image and it would try to sharpen it and edge detect it as best as it could to try to output it to 4K and make it look as close as possible. The advantage of something that's a temporal upscaling technique is that it has more information to work with. It has the depth buffer, the motion vector buffer, and the color buffer. And all of that information can be fed into this upscaling algorithm, FSR 2.0, and then try to mimic what the 4K native image should have looked like. And it can get a lot closer than something like FSR 1.0 because it has access to this more information, which can also come with some downsides in terms of its ease of implementation, which we'll get to in a second. Now, one thing about this is that it's probably going to not ever be able to be added at the driver level the way FSR 1.0 has been added to RSR, Radeon SuperResolution. And a lot of people in my last FSR 2.0 video in the comments were excited about seeing FSR 2.0 in RSR. Guys, I would be shocked if we see it. I guess I can't say it never could, but because they need all of this information, the driver's not going to have that kind of information to my knowledge. So I don't think this could happen. Now, this has to come earlier in the frame pipeline, even earlier than FSR 1.0 did. Because it replaces TAA, post-processing that relies on anti-aliasing needs to be applied post-upscaling, so after FSR 2.0. Whereas any post-processing effect that requires the depth buffer has to be applied pre-upscale. So then they've got this graphic kind of giving you that idea. So you have the render resolution, pre-upscale post-processing, then you do FSR 2.0, then you go into post-upscale post-processing, and then HUD elements and things like that are still rendered at the presentation resolution. So this orange stuff here is done at the native resolution, which can help, again, make it look closer to native, especially when your menus and things look like native. Now, here's where they address machine learning. They try to actually say that this is a net positive, I think. And well, honestly, a lot of people have questioned how much machine learning is actually involved with DLSS. Because, well, here's what AMD has to say. So keep in mind that this is from AMD. So they say often machine learning-based real-time temporal upscalers, which it's very clear that what they mean here is DLSS. They're just not saying it. It says that often they use the model learned solely to decide how to combine previous history samples to generate the upscaled image. And this is the interesting part, and this is what a lot of people are suspicious about with DLSS, is they say that there's typically no actual generation of new features from recognizing shapes or objects in the scene. So I think what they're trying to say here is that the tensor cores doing their machine learning stuff in real time when you're actually playing a game using DLSS, what they're implying here is it's not actually using AI to recognize what the image is supposed to look like and reconstruct it. It's just saying that when you get this information, there's a already pre-decided machine learning algorithm here, like in this box that this stuff gets fed into to get to the output buffer. And they're basically saying that that was, kind of programmed ahead of time, sort of. The machine learning was involved in creating that algorithm, not necessarily in actually AI recognizing what it's supposed to see and generating a better output image because of that. Or so AMD claims. I have to stress that this is all written up by AMD and we don't have third-party testing here yet. Now they're claiming that AMD engineers, who they then talk up with their expert world-class blah blah blah, basically say that they've hand-coded algorithms that do the same thing. So, and they even say that because they have hand-coded it, there could actually be some advantages, because they're saying that they could, when compared to machine learning solutions, the hand-coded versions could have more control to cater to a range of different scenarios and a better ability to optimize. Now, I have no idea if that's true, but that's what they're claiming. But here's the big deal, which should be true, and I think this is the huge advantage. Not requiring dedicated machine learning hardware means that more platforms can benefit and more gamers will be able to experience FSR 2.0. And we'll see a support list here later on down in the article, but basically, the huge disadvantage to DLSS is even if you have an NVIDIA GPU, the odds are you can't use it because you might have a 1060 or a 1070 or a 1080 or a 970 or 960. You can't use it. You don't have those tensor cores. Let alone if you're trying to use it on an Intel or AMD GPU, where it's looking like AMD is going to support both, and we'll get, like I said, more into that later. But here's the big thing. FSR 1.0's big advantage was how easy it was to implement. Well, here's their claim. First of all, Unreal Engine 4 and Unreal Engine 5 just has a plugin, so it can just plug right into that engine. Shouldn't be a big deal at all. And they say that games that already support DLSS 2. Whatever should be less than 3 days of development time to integrate, which is really good news. Because I think because they're relying on the same types of information that DLSS 2.0 or 2.x relies on, a game that's already coded with that in mind should be able to pull that information pretty easily and adapt it to supporting FSR 2.0, which is fantastic. Now, games with support for decoupled display render resolution With TAA would not take quite as long as games that don't already have TAA. That would take longer. And then games without support for decoupled display render resolutions or motion vectors could take around 4 weeks or more to implement. So honestly, here's the big thing. It looks like if a game supports DLSS 2.0, it would not take a lot of work to add an FSR 2.0. And assuming it's roughly as good, even close, if it's even like 95% of the quality, like pretty close, the fact that it'll support a broader range of GPUs is fantastic news, and I think in the long run could give it the advantage. Similar to things how AMD's FreeSync might have some disadvantages compared to a dedicated G-Sync module, but the vastly broader support and all of that, I think could be a good thing in the long run. Anyway, so they've got some information here for if you're looking to integrate this and all of that, but let's go ahead and jump down here. So remember they said that this does support dynamic resolution scaling, but it also supports some specific scaling techniques. Also, they highly encourage developers to provide a sharpness slider to allow users to set the amount of sharpening according to their preferences. And please, developers, listen to them. This is fantastic because a lot of people have a different preference on the sharpness, and allowing that slider is only a good thing. Please do that. Anyway, now dynamic resolution scaling support is fantastic because that's where you basically just say, hey, I want to hit 60 FPS, or hey, I want to hit 80 FPS. And if you're in an easy scene, you might be rendering at native resolution. But if you're in a difficult scene, your GPU might need some help and it renders lower. So yeah, I think that that's fantastic as well. Anyway, here's where we get the details. I'm going to zoom in even a little bit more and maybe slide myself even more out of the way. By the way, the optional here, that's applying to ultra performance, whether or not your game's even going to support that. Anyway, so what do we get here? The modes are going to be quality, balance, performance, and ultra performance, with ultra performance being optional. They describe, what that is, but basically, quality looks the best. And this is the one that they said is, equal quality or superior. This is where they think it could be superior to native. Maybe if it replaces a bad TAA technique, who knows? We'll have to test it out. But then balanced, obviously is going to look worse but perform better. Performance will look even worse but perform even better, all of that. Now, they give us the specific stuff, and you guys, if you're anything like my geometry students, this might confuse you. So the scale factor for quality is 1.5x per dimension, which is a 2.25 area scale. So when you scale the side lengths, the area gets scaled by that scale factor twice, because if your length and your width get multiplied by something, then your area calculation multiplies those together. By the way, it doesn't matter for this, but volume gets scaled by that scale factor 3 times because you also have the depth. In other words, 1.5 squared is 2.25. So you're getting 2.25 the area of pixels if you scale these side lengths by 1.5. That's what this stuff is all talking about. And then also when you apply this the other direction, looking at it as going from output to input, or what percentage of the output is the input, in terms of area, this is a 67% screen resolution. It's actually 2/3, because what they're doing here is basically, for example, 4K output at the quality setting is 1440p input, which is 2/3 of 4K. Okay, in terms of, by the way, I think I'm doing enough math teaching here. I forgot. I am a math teacher, but this isn't math class, so I'll stop. Anyway, but that's what you're getting here. So your 1080p output will have an input of 720p. Your 1440p output will have an input of 960p. Your 1440, they even put ultra wide on here, guys. Your ultra wide 1440p would be ultra wide 960p. Interesting. If I remember right off the top of my head, DLSS quality also does a 1440p input to a 4K output. So that tells me that this is probably roughly the same percentages or the exact same percentages as DLSS. Although don't quote me on that. I don't have them all memorized, and I didn't think to pull them up ahead of time to have as notes for this video. Anyway, we can see balanced is going down to a 1270p upscale to 4K, and so on. We're multiplying the per dimension 1.7 or a 2.89 area scale, or 59% of the screen resolution. Okay, and then performance mode goes down to 50%, which is basically a 1080p upscale to 4K. There you go. All right. So that's what we get. Now, ultra performance is obviously pretty extreme here. That's the kind of settings that, with DLSS, you're kind of using to try to output to 8K or something like that. Okay, so one thing I'm noticing here, by the way, is that these are lower input resolutions than FSR 1.0. FSR 1.0 uses higher input resolutions, but also since they're doing less with that information, I think what's going on here is there's more but more overhead involved in doing this processing. So they're going to need to lower the input resolution to still make up the performance difference they need to make up. But because they have access to more data, it should end up with a better output anyway. I think that's why these would be lower than FSR 1.0. Now, speaking of this, performance boosts, I think this is what they're talking about here. So it will be more demanding on graphics cards than a spatial upscaling solution like FSR 1.0. So again, they're saying the same thing I was just saying. This will be more demanding than 1.0. So gaming experiences may vary depending on specific system specifications, the requirement of individual games that support FSR 2.0, and the target resolution. But they do say that gamers may be able to have a good upscaling experience on lower performing or older GPUs. So they want to support older GPUs, but they're warning that the overhead involved in this processing could be rough on older GPUs. Now, the information they're giving here are based on a beta of FSR 2.0, and they'll be updating this. But here's what they're basically saying. So in quality mode, with auto exposure, no sharpening. Okay, here's what they're saying. On an enthusiast class GPU, like the Radeon RX 6800 XT, upscaling at quality to 4K, right? So that's your 1440p to 4K. They're saying that it would take less than 1.1 milliseconds of, what did they call this here? The upper bound of performance overhead. So remember, like FPS, frame rates, right? Frames per second. That's a measurement of how long it takes to produce the next frame, right? How many frames you're producing in a second. That's the idea. So they're saying that it's less than 1.1 milliseconds. So 1.1 milliseconds is the upper bound in how much extra processing time it takes to apply the FSR 2.0, process to your 1440p render image to get your 4K output. And they're saying that at 1440p on like a 6700 XT should have an upper bound of less than 0.8 milliseconds. And a 5700 XT mainstream GPU should have an upper bound of 0.6 milliseconds when upscaling to 1080p from, what was that, 720p, I think, for the 1080p quality. Now at performance mode, notice that we get some more numbers here. You can see them for yourself. I don't feel like I need to read them all out to you, but that's what it's saying. I think that's how much processing time that takes to add on to your frame time. Okay, and the system that they used here was a R9 5950X, and they give us the GPUs and the tables and the drivers. Okay, they also give us some image comparisons. Now in a video, I already in my last video zoomed in on their previous video, which shows things in motion. Here's some little side-by-sides and such. And I've got this very, very, zoomed in as much as we can. So you can see as we slide it back and forth, the two images look very similar. Now, which one is better? FSR quality is on the right, the native image is on the left. And honestly, there does seem to be a bit more aliasing in the native image here as I slide over it, but is that just a little bit blurrier with less aliasing? Question mark. Then this certainly looks a bit sharper and more detailed to me here than there. So there's definitely differences to the image. It's not identical. I think I'm seeing the individual little shutter lines better here. But again, I'd encourage you to come to the actual website here, and I'll link this in my description, because also that these are, these are crops and are not like super high resolution, taken from a 4K frame in Deathloop, but they have the full size 20 megabyte each screenshot here, which I would again encourage you to actually download. They also have their video they've shown with this in action, which in my previous video, I actually zoomed in and slowed down and all of that made available in side-by-sides. Okay, So they're also excited to announce that another game will support FSR 2.0, which is Forspoken, which is very interesting. That's coming in October 2022. And so basically we have confirmation that there are at least 2 games. It's not just Deathloop, it is Forspoken. And they've got a bunch of FAQs. When will this be available? Well, again, they're releasing it very soon. What was the exact date? I know they've said that FSR 2.0 is coming Q2 2022. And they've got a plugin coming for Unreal Engine, samples for DX12, later, Vulkan's coming later, all of this. Anyway, I'm very, very excited about this. What are my overall impressions? I think this is exactly what AMD needs. It just needs to be almost as good as DLSS, and it needs to be supported in most titles that support DLSS. And it looks like, based on that graph that showed us, that it'll only take a few days to add it into a title that already has DLSS support to get us there. Because, yeah, in my AMD versus NVIDIA comparison videos, that kind of a thing, my biggest conclusion is that, well, I'd rather just play games at native resolution, right, than use DLSS. DLSS versus FSR was a big win, and it adds a lot of value. For people willing to make their image quality just a little bit worse for a huge boost in performance in games where it's available, that's a really big deal. And I could see, if this continues to be supported years down the road, helping your GPU last longer. Maybe you can skip one upgrade cycle because, oh well, I'll just use some upscaling. Instead of buying a whole new GPU, things will look slightly worse, but I'll get the performance that I need. Overall, this is really exciting. I can't wait until we can actually try this out in more games. But where are the GPUs? Like which GPUs does it support? I thought I had it pulled up in this article somewhere, but did I not? You know what, guys? We're gonna jump over to video cards because I know they had it in one of the slides that they showed. Here we go, guys. So right here, we do see that there are graphics cards being listed as targeting, including the 16 series, the 1070 series, that this might work at 1080p. They're saying that based on the, this is optimal starting level hardware. So this, I think they're getting into that the overhead involved in this could make it difficult to run on older GPUs, but at least that's better than, you know, NVIDIA saying that, you know, you just have to have an RTX card. AMD is going to make this a lot more open. We don't see the 1060 listed, but I will certainly be testing this out on the 1060 once it's available. And I'm sure we'll get more information about this in the near future. And I hope all of you guys have an excellent day.